here we need to create our first lambda through this Terraform script. And what this Terraform is doing, we are setting up our infrastructure as a code. So this Terraform is nothing but a infrastructure as a code. And you can say the infrastructure is like services on AWS console, like EC2, AWS Lambda, IAM role, S3 buckets. Okay, so these are the services we are using as a code. So we say that this is the infrastructure as a code. So let me write this code for you, and let me tell you one thing. This code, you don't need to remember these codes. This code is available on the documentation of HashiCorp's website or Terraform website. I will tell you how we can get the code, and what is the process we are going to follow in the Terraform scripts. You just have to keep remember on this. Okay, so what are the steps we need to follow. So let's go to the browser. Okay, so the first thing we are required here is the provider. Okay, so provider is what? The provider is like, we need to tell the AWS, we need to tell the Terraform uh, that on which reason you want to deploy the application. Let's suppose if I want to deploy the application US East 1, then I have to give the value of US East 1 in the provider. So this Terraform will understand now. Now this will deploy this application on US East 1. Okay, so for the provider, let's go to the website and type registry.io, or just type Terraform documentation. And you just have to open this registry.terraform.io. Just click on this. You'll get this AWS documentation. Okay, and in the AWS documentation, see, the first thing is AWS provider. You don't need to search anything uh, right now. So just a provider, you just have to use this one. The first thing we need to configure this is the provider. The provider is US East 1. Here you can change your reason if you want to deploy on US East 2 or some other reason on the AWS. Now the second thing, this is done. The second thing is we have to create a IAM role for our Lambda function, right? So we need a separate IAM role to execute this function. So for that, let's go to the documentation and search here IAM role. Okay, AWS IAM role, and you just need to copy and paste all of this thing. Okay, just copy it and paste it. Okay, so this is the resource. I mean, you can't change this. If you change this, then this will not work. And this is the name. This is the test role. You can change this. Okay, this is the reference name, so you can change the reference name. So role Lambda role. Okay, and I will use the same name, Lambda role. So the Terraform JSON function converts a Terraform expression result into valid JSON syntax. So this is the policies which is going to be attached with this Lambda role. Okay, this is the tag key. This tag key is not required, but this will be beneficial if you track track your costing in AWS console. Okay, so this is quite helpful. So let's say if you type Spring Boot Lambda here, so all the services which has a tag Spring Boot Lambda is going to be tracked down on the billing and management page, and uh, you will get a track on how these services are costing. Okay, and how much cost is applied on these services. So for now we are using the free tier account, so we don't need to track on cost and billing management, but this is beneficial. I mean, we should have this tag key on every services. So this is created. Now the IAM role is created. Now the next thing we need is we need to attach the policies on this IAM role. Okay, so first based on our Spring Boot application, we need just a basic permission on the Lambda. Okay, so let me write a code, search a code from here, policy attachment. Okay, so the policy attachment you see here is, yeah, this one. Okay, so this one is taking the policy attachment JSON. And are we using JSON somewhere? This is the JSON, I think. This is the import. Okay, this is the import. Okay, we will use this. We are not going to create another JSON file for that. We are using this. So this is the resource name. We are attaching the policy to our Lambda, to our IAM role, which we have created just now. And this is the resource name, so we can change the resource basic permission, and this role should be which role? This role. Okay, so you are going to attach the basic permission on which role? On this role. So this is the resource name. The second one is the resource. This is the resource name. Oh, sorry. This is the resource type, and this will be the resource name. What the resource name we are using, and this is the parameter inside we are using inside the curly braces. Okay, so name we're using the name. Okay, so this policy ARN we can hard code it for now. So let me go to the IAM console and we'll search for the basic permission, Lambda basic permission. So this is, let me open any of this. Let me add a permission so we can see the ARN of the permission. AWS Lambda basic execution role, and this is the ARN. We can copy and we can paste it here. So now this policy has been attached with the role we have just created. Okay, so these two things is done. Now the next thing is we have provided the provider, we have created the AWS IAM role, we have created a policy attachment. Now we have to create our policy Lambda function. Search for Lambda, and yeah, this is the resource we are looking for, AWS Lambda function. Copy this resource, and we want only this. We want this. Let me copy and paste it here. So this is the resource name. No, this is the resource name for creating Lambda. This is test Lambda. So the test Lambda will be like terminal geeks Spring Boot SP Lambda, and let me use underscore for this. Underscore but, and here the function name will be like this, and the file name will be, okay, we are uploading the jar file of our Spring Boot application, so we'll give the path of this. For now, just skip. The role we are attaching is AWS IAM role for Lambda, and our role name is, resource name is this, and ARN. This will generate the ARN automatically. Handler will be handler class. So whatever handler class for the Spring Boot application is when you go to this, and the method name is handle request. Okay, so the runtime will be Java 11, and this is the environment variable if you want to take. So let's take the environment variable name is application underscore environment. So the current environment for us is a dev environment, let's say. Okay, so this is the environment variable we are adding in our lambda function. So we'll check, we'll see where it will be created. Now the file name, the file name it is taking is a zip file. Okay, but uh, we are going to upload our file as a jar file, because this application, this Spring Boot application is giving us the jar file. Okay, so let me build this application first. Okay, so application is built successfully. Now let me refresh it and open my target folder. So this is our newly generated jar file. Okay, so I'll go to the property, I'll copy this path and paste it here on the file name. So what it will do, it will create a lambda function. It will take the file, this jar file. This function name is terminal geeks spring boot lambda. This is going to attach the role which we have created here. Okay, and this role has some policies attached, which is AWS Lambda basic execution role. Now this is our handler class. When this jar is going to be uploaded, this needs to be invoked via the handler class. This source code hash code is not required, I think, for now. So let me comment it. Runtime is Java 11. We are taking Java 11, and the environment variable is tab. Okay, so I think we are done here. Now what we can do, we will open a new terminal and we'll type first Terraform in it. Okay, so let me create one readme file, readme. Okay, and here we will keep all the commands. First we are going to initialize our Terraform here. So on the left panel you will see some folders will be created, some files will be generated automatically when we initialize our Terraform. Okay, so you can see here the Terraform has been created successfully. Now before deploying any application on the AWS console, we have to run this Terraform plan. So what it will do, it will check whether it is ready for a deploy or not. I mean, if it is having some problems, so the plan will give you early indication that your Terraform scripts has having some problem. And what it will do, when we do Terraform plan, it will create a Terraform state file. Okay, it's not created yet, so it's successfully done. Okay, so 3 to add, 0 to change, 0 to destroy. Okay, so the last command we have to run is Terraform apply. Okay, so Terraform will perform the action described above. Only yes will be accepted to approve. Okay, so when we write yes and then enter, then only it will going to approve this, and the services are going to be deployed one by one on the AWS console. So when it is deployed successfully, we will check on the AWS console. Still it is deploying. Okay, so here we are getting some error. So creating lambda function operation with AWS. The role defined for the function cannot be assumed by Lambda. Okay, so let's go for the role. Okay, so let's check one by one what this role is doing. Lambda role is the name. Okay, this is the okay, I think I got it. We are attaching this role to our EC2 instance, but our function is Lambda, so we have to change this for Lambda. And let's do apply, and this time I'll apply auto approve. Okay, so what auto approve will do, this will not ask us to for the confirmation of yes or no that you want to apply or not. So this is completed, see, and this is completed under 16 seconds. So let me add this command, auto approve. Okay, so the resources has been added. So let me check on the console. If we refresh, yeah, so we have this function has been created 39 seconds ago. If you open this, okay, our jar file has been attached because the package size you can see here is 15 MB. So this is attached. We have also configured this handler class. This is Java 11. So yeah, this is done. Let me go into the configuration. If you see the configuration, we have added some one environment variable with our Lambda function, which is application environment. So yeah, it is you can see it here, and I'll show you later how to read this environment variable from Lambda function on our Spring Boot application. Okay, and in the general configuration, the timeout is 3 seconds because we did not mention any timeout here. So let me run this application first. Okay, so API gateway is created or not, because API gateway is required to run this Lambda. Okay, so we need to create a API gateway for that. So okay, let me create a file for API gateway, and this is the code I've attached with the API gateway, and this API gateway Terraform script line by line. So our first resource is AWS API gateway REST API. So this is what we are defining here, that the name of our API gateway will be sb underscore lambda underscore API. So this will be created under this name. The second resource is API gateway resource. So when we create API gateway, we have to create a resource path on the API gateway. Let me show you on the AWS console. So let's suppose this is the API gateway, and this API gateway we have created earlier while we were creating manually in our previous video. So what the resource is created, this resource was created like this, where it is taking any path variables or any custom path values of the API. So this is the uh, resource ID we are creating through Terraform script. Okay, so this code is for that only. The third resource is AWS API gateway method. Okay, so we have created the method under the resource ID, and this method is get method, because we have only one method in the API right now. If we have more, then we have to create more APIs like this, how we have created in the resource in the API gateway script. So this is the resource for API gateway method. This is the integration method, you can say that. Okay, so this is taking REST API ID, this is taking the resource ID, and this is taking the HTTP method, this is taking the authorization, which is which is none for now. Okay, later we can add some authorization which will take XAPI key from the environment. Okay, so the next resource we are required here is Lambda integration. So we are calling this we are creating this API gateway, and we have to call our Lambda function from this API gateway. So to communicate between this API gateway and that Lambda function, we should have some communication between these two services. So these services always cost a post method. Okay, and this is the integration method, we can say that. So this API gateway calls the Lambda using the post method. So this is, you can say that this should be by default post, so you can't make it get or any other HTTP method. So this is by default. So and the type is AWS proxy. So what it is doing, it is calling our Lambda function, and our Lambda function is we have given the URI. Our Lambda function is what we have created in the lambda.tf file. So this is our Lambda function. Okay, and this is the invoke ARN of that Lambda function. So what it is doing, when I go to get integration request, so here you can see that our Lambda function it is attached with this method. So that's why we are using this Lambda integration. This is required, otherwise that API gateway won't work for our Lambda function. So the next thing is that we are attaching some policies to our Lambda function to execute this API gateway and to communicate this API URL with the Lambda function. So for that, let me show you where it will be created. When you open your terminal Geeks Lambda function, and when you go to the configuration and some permissions here, so this is the role we are attaching, but this policy is directly attaching with the Lambda function. So you can see here resource based policy statement. This is by default policy attached with this. Okay, but if we add policies like this, so you will find your policy here as well, with the same name, the statement ID. Okay, you won't get some random UUID here. You will get the policies with this name: allow execution from API gateway. And this is also required, otherwise your API gateway can't communicate with the Lambda function. So the last thing for now in this API gateway is your deployment. Okay, when everything is done, when all the configuration part is completed, then we need to deploy our API gateway on some stages. Okay, so currently we are using dev, so we can deploy our API gateway on the dev environment or any other environment you want. So this is the variable name you can change. You can do anything like test environment, prod environment, like that. So yes, these are the some resources we need to create before creating API gateway. So let me do plan again. Okay, plan ran successfully. Now I'll do Terraform apply for auto update, auto proof. Okay, so it has been added. So let me go back to this. Okay, we forgot to add the timeout. Okay, we'll do it later. So let me go back to the function again. Function is created already. Now API gateway. Go to API gateway. Spring Boot API. I think yeah, this is created just now. API gateway. Open this. Stages, gone stages. Okay, when you check on resource, we have this resource ID and we have this get method. Okay, now go on stages, click on the invoke URL, open Postman, and our method name is test only. Okay, internal server error. So I think that timeout is the issue. So let me go on the Lambda function and check on the cloud watch. Yeah, the timeout was the issue. So we have to mention the timeout on our Lambda function. So I'll get timeout to 900. Okay, so 900 is the max timeout time. I'm not doing plan because this thing is, this is not going to create any issue. So timeout is 900. This is the max timeout. We can't add more than that. Okay, so apply is completed. Let me go and refresh this. So you can see here timeout is 15 minutes. Now I can test my application. And point request timeout, let me hit it again because uh, function is not started in 29 seconds, so I'll try again. Let me open CloudWatch so we can monitor. Okay, so we are having out of memory, so we have to provide one more thing is in our Lambda function is memory, because we have not added memory in our function. So I'll add memory size. Memory size is I'll give this to 1 GB. I'll do Terraform apply again. Okay, apply is completed. Let me start the CloudWatch again, and I'm going to hit the API. Yeah, so we are getting the success response now. This is the older log, I think. So now we are getting the success response. So we have completed our first chapter successfully. So what was in the chapter we have covered? We have covered the Spring Boot. We have created the Spring Boot application for the Lambda, and we have created the API gateway. We have deployed it on the AWS console manually and with the Terraform as well. So this all the 5 points has been completed successfully. So uh, I think we are done here. And yeah, if you want this code, then please do like, subscribe, and share this video, and send me a mail on my email address. I have attached the email address on the description of this video. So mail me on that. I will give you the GitHub repository where you will find the code of this. of this Terraform. So that's it for now. Please do like, subscribe and share this video. Thank you so much.